Welcome to Geeking Out. I'm Pete Stagman, and this is my lab. I wish. It's a green screen. So, what is Geeking Out? So what we have here is a Mosaic Manufacturing Palette 2S Pro. What does it do? Well, if you're into 3D printing, you know that 3D printing, you can basically only do one color with most machines. You can, pick a color to begin with, and that's what you're going to get stuck printing with. Now, most 3D printers don't really print in color. They print in whatever filament you put in. So if you put in black filament, it prints in black. If you put in blue, it prints in blue. So I have some filament here. You can see here's a nice this is a translucent yellow filament. This is a black filament. Here's blue filament. And here's some copper metallic filament. Yeah, you can even print in stuff that looks like metal. Now, most 3D printers can only print a single color. So whatever reel you put on, that's the color that it's going to print. There are some other 3D printers that do multiple colors. They can do 2, 3, 4 color. But the way that those work is that they have the 4 different spools going into a print head that has 2, 3, or 4 different print heads on it. So you have one for blue, one for red, one for yellow, whatever. And the problem with that is they're, 1, really expensive, and 2, they take a really long time to print. If you're not familiar with the way a 3D printer works, they work kind of like a hot glue gun, where you put in the filament in one side, the trigger pulls, it goes through a heated nozzle, and out comes a little stream of glue. That's basically all a 3D printer does. It just does layer after layer after layer of glue. Now, with the multicolored 3D printers, each one of those colors goes into a different glue gun. And in order for that to work, it does one color, and it does everything it can on that layer, because it builds it up in layers. So it does everything it can on that color and that layer. Then it stops, it moves out of the way, it cools off that one, and then heats up the next color. Then it comes back, and it starts printing in the next color. Then it stops, and it moves away, and it cools off that print nozzle, and then it heats up the other one, and then away it goes again. So what this little guy does is it takes 4 different colors and splices them together so that they're into one. Now there's a piece of software that you need so that when you create your print job, it divides the job up into the different colors. The software knows exactly how long each of those colors in the filament has to be. And as it's running, it gets to a new color, it cuts off whatever color it was doing, runs up the new color, splices them together, and then runs that out to the printer. The printer has no idea that it's printing in different colors. It just goes and does its job, doing it layer by layer, thinking that it's just moving along in one color, and this little guy is changing the colors as it goes along. Pretty cool. So here I have the palette set up next to one of my print tents. And right now I've got 4 filaments in. I've got a red filament, a blue filament, a black filament, and a white filament. And I'm running through the first calibration. What it's doing right now is it's measuring out different lengths of filament and cutting them and splicing them together to making sure that it does work with those particular filaments. So as you can see here, it's you can see the little blades moving, and now you see the filament coming out, and it's almost done. And there we go. And you can see that we have a blue and a red spliced together. So it's actually been about 2 weeks since the palette showed up, and it's not that it was that hard to get it to work. I actually had to use my 3D printers for business, and I had to stop to not play with some toys for a little while. But when I did get back to it, there was a little bit of a learning curve. Not that anything was too difficult to get, but I did have to sort of figure out their software and how it goes together. The other problem that I had was, even though the palette comes with some adapters for a bunch of different types of printers, mine wasn't one of them. So I had to make something to get it to work. But I'm going to show you what I printed, how I printed it, and the result. Okay, so since I didn't have any 3D models that were multicolored, first thing I did was go on to Thingiverse and search for some multicolored models. Now, Mosaic uses a clownfish for their ad, so I figured I would use a clownfish to test it with. And I believe this is the same model that they use. So first thing I did was download it and import it. First, I'll import it into Simplify 3D, and that's just to show you what the different models are, because there has to be a separate model for each one of the different colors. I don't know why it keeps doing this, but we'll do that. So here's the model, and it's split up into the different colors. I'll try to zoom in a little bit here. So here's one color, these would be another color, these would be another color, and I believe those are the eyes. Yeah, so those would be the eyes. So those are the black, the red, and the white, or the other way around. White, red, black, and whatever color we make the eyes. So the only reason I brought it into Simplify 3D was to show you what the separate colors look like. Now I'm going to go into Canvas. And this is Canvas. So this is Mosaic's own software. And what we can do is we can actually pick colors. So let's say I'm going to pick black, and we're going to make that black, and I'm going to drag it into the black outlines, and then we're going to pick red, and I'm going to put that into there, and then the next one is going to be, they have it listed as light green, but I'm going to make it white, and we're going to drag that over to here. So there we go. So now we're set up with our colors. Now what a slicer does is it takes this 3D image, and because a 3D printer builds from the bottom up layer by layer, what a slicer does, if I click slice here, it's actually going to take that model and divide it into layers depending on how high I set each layer to be. And I believe on this one I set it to print fast, so it's going to be 0.3 millimeters on each layer. I think, which is, I wanted it to print fast. I really didn't care about high quality. So like fast is 0.3 millimeters, decent quality is 0.2 millimeters, and high quality is 0.1 millimeters. So I'm just going to let this slice. And it's almost done. And I think when I did this originally, I thought it was taking way too long, but it just seemed to work. Yeah, they've updated their Canvas software, which is actually a website. It's very different than when I actually did the print. So then I would click on Send to Canvas Hub, and then I would go to the Canvas Hub, and it's not connected right now. I've got it disconnected because, as you can see, if I go over to Control, it's actually printing out products for my business. So, but this is how we make a time lapse. Canvas Hub is an Octopi, a custom-built Octopi, which is a print server for 3D printers. So it's just their own modified software, but it did come in handy to do the time lapses with. And that's it. Then I'll show you what it actually did. So here you see a time-lapse video of our little clownfish being built up layer by layer. It's about 1.5 minutes long. In reality, it took like 7.5 hours. But you can see here that it's doing a fairly decent job of splitting up the colors. But later you'll see that when I do a close-up of it, it really didn't do all that well. So here's our little clownfish all grown up, and as you can see, the lines on it, the black where the white should have been, and white where black should have been, and red where black should have been, and black where red should have been. So it did make some mistakes. I mean, overall it's not too bad, but you can definitely see the layer lines. But like I said, that's because I had the layers set for fast, not high quality. I don't know if doing it in high quality would have made a difference, because I did do something else in a high quality to see if it would work. And you can see that here. If you're not a Patriots fan, I'm sorry, but I was trying to do a Patriots logo. And on this side it looks great. I mean, that's how it's supposed to look. But if I flip it over, and this is actually the side that you would use. This is supposed to be a coaster. You can see that it completely reversed the colors. Now, another problem that I have with the way that the palette works is that it creates what's called a transition tower, meaning that anytime it changes color, it cleans out the nozzle by going over to this transition tower and building it up so that you don't get a blend of colors like what we see here, but which didn't work out so well. Now, to me, this is a huge waste of filament, and I'll show you that in a second. So I'm going to bring over my little post office scale here. I'm going to turn it on. And as you can see, it's set for kilograms. Now, here's the weight of the actual little fish, and it's 0.03 kilograms. You know, so that's not bad. That's a fairly useful amount of filament. But now I'm going to do the transition tower, and it's 0.118 kilograms. it's 3 times as much filament being wasted on the transition tower than was in the actual print. So until Mosaic comes up with a way of not wasting quite so much filament, I don't know how much I'll actually be using this. So all in all, the palette does what it says it does. It does make a 3D print in color. I'm sure that I could probably get it better if I do some more tweaking, just to try to get the prints better. The instructions say that it learns from each print, so it's supposed to get better and better and better the more you use it. But I don't know if I'm going to be able to justify it, printing anything in color because of how much is actually wasted. That's it for our episode this week. Hopefully next week I'll have some new gadget for you. See you then.